In this lesson, I'll show you how to identify similar triangles. Remember what a similar triangle is. It's two or more triangles of different lengths, but all have the same angles. In question number 1, we're asked, identify a pair of similar triangles and explain why they're similar. Support each statement with a reason. Take a look at this figure. We have a right triangle, and that's defined as x, e, and t. So let's write that down. You can show a triangle by writing out this little triangle symbol and writing out x, e, and t. That's one of the triangles. The other triangle is x, n, and p. X, n, and p. Since this is a right triangle within a right triangle, we can say that the angle for p, which you always represent as x, p, and n, notice that the angle in question is p and it's in the middle. Always the angle that's in question is in the middle. This has to be equal to angle t, which you represent as angle x, t, e. Once again, t is in the middle. That's the one we're referring to. That's one proof that these triangles may be similar, although we still need to provide more proof. Now, because x is a common vertex in both triangles, we can say that angle e, x, t is equal to angle n, x, p. And if two angles in a triangle are the same, then the last one also has to be the same. So angle x and p is equal to angle x, e, t. And because all three pairs of angles are equal, we can say that the triangle x and p is similar to, this symbol represents similar to, triangle x, e, t. Keep in mind that when you write a similarity statement, the order of the vertices must correctly identify the pairs of equal angles and pairs of corresponding angles. In other words, notice that we wrote down x and p and then x, e, t. The x's are in the right place, the e and the n are in the right place, and the t is in the right place. Let's move on to question number 2. Here we're asked, are the two triangles in the diagram similar? Explain your reasoning. Triangles are similar if their lengths are proportional. And if their lengths are proportional, that means their angles are all the same. With that being said, take a look at this line relative to this line. The length here is 25 and the length here is 5, so we have a ratio of 25 to 5. This side and this side can also be compared. We have 20 to 4. And this length and this length can be compared. If we reduce these ratios down, we end up with 5 to 1, 5 to 1, and 5 to 1. This means that the larger triangle is 5 times larger than the other one in all three sides. Therefore, the triangle EDC is similar to the triangle ABC. Let's write that down. Triangle EDC is similar to triangle ABC. And there you have it. 2 examples on how to identify similar triangles.